Hello students, in today's session we are going to see question number 2 and question number 3 of exercise 1.3. In the last session we have seen how to prove uh, root 5 is irrational, and even I gave you few questions for extra practice. Now in today's session let's continue with question number 2. We have to prove that 3 plus 2 root 5 is irrational. So we follow the same procedure, that is contradiction method, which I explained you in the last session. So in contradiction method what happens, we assume the opposite. So we have to prove 3 plus 2 root 5 is irrational, so we'll assume it 3 plus 2 root 5 is rational. Okay, so let us assume the opposite, 3 plus 2 root 5 is rational. So I said you every rational number can be written in the form of a by b, where a and b are some integers. Okay, however I get a and b. Okay, like if I take a plus b by 2, this is also rational number. Okay, where a and b are some integers. In place of a and b, if I write 3 plus 5 by 2, that is 8 by 2, that is 4. Okay, so a and b can take any values. Okay, like here I took 3 and 5, it can be any number. So a and b are any integers here, and that will give you a rational number. So here in this type of questions where there is rational plus irrational, okay, you can check this is combination of two numbers. In the last session we have seen only a single term, that is root 5. That is different method. Here it's very simple method, will not go so long. So here what we do, so we assume this is rational, so 3 plus 2 root 5 is equals to a by b. In this type of questions we'll keep root term, that is root 5, alone on the left, and we'll transpose all the numbers to the right, that is 3 and 2 I'll transpose to the right. This is the basic thing in this. We should keep the number in the root on the left alone and transpose everything to the right. So this 3 goes to the right, become minus 3, and if I do the LCM of this, a minus a by b minus 3 by 1, the LCM is b. Okay, you can see here the LCM is b. Cross multiply a minus 3b by b. Okay, so this is the way we proceed. Now still 2 is remaining here, even this 2 I'll take in the denominator in the next step. So here you can see this 2, the 2 came here and became 1 by 2, or you can write it as 2b directly. Okay, 2 was here, it came in the denominator here now. So only root 5 is remaining alone on the left. So this is the procedure we have to follow for any type of question, whatever may be the numbers. You should transpose everything to the right and keep only a number in the root. So root 5 is equal to a minus 3b by 2b. This a minus 3b by 2b will be rational. Just now I said you can take a and any value for a and b and simplify it, you'll get a rational number. So, and we already proved yesterday that root 5 is irrational. Yeah, in the last session we proved root 5 is irrational. So can rational be equal to irrational? Yeah, it's impossible. Okay, so here a minus 3b by 2b is a rational number, as I said you, and root 5 is irrational. So rational can never be equal to irrational number, like even number cannot be equal to odd. Okay, so rational can never be equal to irrational. So this is a contradiction, means our assumption is wrong. So yesterday I said you we assume in the opposite way. Okay, the same thing we have done here also. So this is a contradiction, our assumption is incorrect, hence 3 plus 2 root 5 is irrational number. This is the way we have to proceed with the next question also. 1 by root 2, Now we'll assume again the same thing, assume the opposite. It is, let 1 by root 2 is rational number. Again the same thing, same steps, there is no change in the steps. You can see I'll write 1 by root 2 is equals to a by b. Now here you can directly reciprocate it. Okay, a by b is equal to 1 by root 2. You can write b by a is equal to root 2 by 1. Whenever you have like this, you can do in this way. So I can directly write root 2 is equals to b by a now. Yes, so if you have a single term, just reciprocate both the sides, you will get directly root 2 on the right or left, any one side. Okay, so root 2 is equals to b by a, but b by a is rational and root 2 is irrational. So again we write the same steps. Okay, b by a is rational, root 2 is irrational, but rational can never be equal to irrational. Very important step. Again the same step, these steps remains the same for every problem. Same story you have to write in every problem. Just you have to bring this to this step, root number alone on any one side, and write the same steps by changing the number. Okay, next, here again we have another question, 7 root 5. For 7 root 5, again we suppose the opposite one, assume it as a rational number, so this can be written in the form of a by b again. So 7 root 5 is equals to a by b. If I take this 7 in the denominator, we get root 5 is equals to a by 7b. Okay, again root is on the left and a by 7b. So a by 7b is rational and this is irrational. So again we write rational is not equal to irrational. Very simple and very important concept. If you concentrate, you can easily understand, and you can even do it in exam also. So again I write this is contradiction, so our assumption is incorrect or wrong. So hence 7 root 5 is irrational. The last bit also I do in the same way, 6 plus root 2. I take 6 to the right, same thing. I suppose all the steps are same. Okay, assume it as opposite. This is rational, then this can be written in the form of a by b, then a and b are co-primes, same thing. Okay, nothing, there is no change at all, only the changes in these terms. So 6 comes to the right, and if I do the LCM of this, a by b minus 6 by 1, LCM is b and cross multiply, you will get a minus 6b by 1. So you get a minus 6b by 1. So this is rational and this is irrational. Okay, as it is written here. Then rational is not equal to irrational. Again the same steps we proceed with. Okay, so this is very important concept for 3 to 2 marks. This can be asked in 3 marks or even 2 marks in the exam. So complete this and don't forget to do extra questions which I am going to give you from this. Thank you.